It's rejected because the remote branch is ahead of your local branch. This means that the remote branch has newer commits that your local branch doesn't have yet. But there's an easy fix. You just do a git pull to get the new changes and then... Actually, here's why you shouldn't do this. When you do a git pull in this situation, you're actually creating a fresh merge commit. You see, what happens is that your commit and John's commit both had the same ancestor. So by default, git pull will merge the two new commits together by creating an entirely new commit, like this. If everybody on the team does this, over time you'll just end up with a confusing commit history with a bunch of extra useless merge commits in it. This makes it really hard to navigate the commit history. For example, when you're looking for a specific commit in which a certain feature was worked on or a bug was fixed, because then you have to sift through all those useless merge commits first. What you usually want to do instead is to just put your commit after the other person's commit. That way the commit history will stay linear and clean. So instead of using the regular git pull, which creates the extra merge commit, use git pull rebase. What does that do?
Let's rewind first to the initial situation before we did the regular git pull. Alright, so git pull rebase will take your commit,
temporarily put it to the side, do the git pull, and then it'll try to put your commit back on top. This even works if you or the other person did multiple commits. But wait, I hear you say, what about merge conflicts? What if the changes the other person made and my changes are in conflict? Normally, when you do a regular git pull, you just get a merge conflict that you can then fix. When you do a git pull rebase, you of course still can get merge conflicts. In that case, Git will tell you though. Then you can just undo the entire pull with a git rebase abort. This will undo everything and restore your local repo to the state it was in before you pulled. Then you can just pull normally with the regular git pull and fix the merge conflict as you usually would.
So to summarize, when I work on a project, I almost never use git pull, but instead I always try git pull rebase first. If it works, you're already done. If you do get a merge conflict, you can always undo the entire pull with a git rebase abort.
Hey guys, how are you? So, what is the Java job delusion? Let me start off by saying that I have written more lines of Java code than any other language, and I've written commercial code in 8-9 languages. So I love Java. I'm not doing a hit piece on Java here, but I'm going to give you a little bit of reality about what Java is all about with regards to the job market, which I think for most people, that's what they're most concerned about. Writing Java code means certain things about the type of work and the type of place you will work for. So when you look at Java, it was initially sold as the multi-platform language, multi-use case language. Believe me, I was there in '95 when it was released. Java was sold as a potential language for creating games, for desktop applications, now for mobile with Android. Use it for IoT devices, web apps, etc., etc. This is all true to a certain extent. But the reality of the situation is the vast majority of Java development is server-side web app development and perhaps a slice of Android development, native mobile Android. But because Google said a couple of years ago, nope, the number one choice language to create your Android apps in now is Kotlin. That's another story. But anyway, most of the jobs, though, are going to be in Java server-side programming and a smidge of Android development. So what kind of web apps are we looking at in the Java world? Well, we're looking at large web apps, big web apps. We're not looking at the light, nimble startups. Again, Java is, like, in my heart, is my favorite language. I love Java. I love the explicitness of the code. It's easy to read and understand. The problem is Java is extremely verbose. You have to write out all that explicit code, and it takes time. It takes a lot of time. And as I say, in many videos, I've said many times, I said write time speed is far more important than run time speed. Let me say that again. Write time speed, the speed of writing with a particular language, is more important than the speed at which the language code runs. That's because software is so optimized these days. The high-level languages, the dynamic languages like JavaScript, Python, PHP, Perl, they don't run nearly as quick as Java. Not nearly as quick as Java, except for maybe JavaScript, but I would have to check into that. But generally speaking, Java, when it compiles, it's super fast. It's very performant at runtime. The problem is it's going to take you forever to write anything in Java because that code is so bloody verbose. So even though I love Java, I would not use Java to build any minimum viable product application today. No MVPs in Java for me, that's for sure. I would use Java only in highly specialized situations. Anyhow, that's just me. But it's a lot of other people too. The trend is, in terms of new development, from scratch development, fresh development, is with the later, nimbler languages like the JavaScripts and the PHPs and the Python. But you still see a heck of a lot of Java jobs. Where are those jobs? That's the question. So all the Java jobs, well, the vast majority, are going to be in larger organizations, mediums to large businesses. Think big banks, etc., government, that kind of thing. That's cool, but that means that you're working for a particular type of company, a particular type of organization, which suggests a certain work environment that you may or may not like. So anybody will tell you, if you work for a large organization, you're dealing with HR departments, you have to deal with interpersonal politics. So again, the number two thing, I say again because I talk about it in many videos, the number two things that recruiters look for in their developers, the number two thing that recruiters look for in their developers is their interpersonal skills. This is especially true if you're going to go work for a very large organization. That is huge. I talk to people, I never have personally. I've worked in one as a hired gun for like 2-3 weeks. That's another story. I've never have full time. but I know several people who have or had, and it's a different game than working for a small startup or a small business. It's much more regimented, much more controlled, much more about politics and crossing your T's and dotting your I's, HR departments, that kind of thing, dress codes, et cetera, et cetera, et cetera, et cetera. So you have to think that if you are going to get a job in Java world, it's probably going to be web app, maybe some Android development, but more importantly, it's going to be for medium to large organizations. And the final point, you're probably going to be working on legacy code bases that are being maintained or expanded, not from scratch. And again, that implies a whole different type of development. When you are looking at legacy development, maintaining old apps or expanding them, that implies long development cycles. So you may be working on a particular project, a particular code base for a year, 2 years, 3 years, or longer. Again, that may be something you like, but if you're somebody who wants to be able to build something over here and then build another type of app and then finish that off and launch another type of app, if you want something a little bit more dynamic, you may not want to jump into the Java world. That type of stuff is more akin to the lighter, nimbler languages like the JavaScripts and so forth. Again, these are generalities. These are not, there's always exceptions to the rule, but the JavaScript web world is being stuck on working on a particular feature for a long period of time, just something to consider. So the final point, when you're doing Java development, because you're going to likely be working for larger organizations, the chance for remote work are less. That being said, post-COVID, there's more opportunity for remote work in the Java world, no question about that. But it's much more common in small business because small businesses are not so bound by culture. And culture is a big part of the impact of how a developer lives their day-to-day life as a developer working for a company. Big corporations tend to have very strong cultures based on old models of running a business, where they want people to show up at work a lot. And you see that now. There's a big battle brewing out there in the world between management wants people to come in and between coders who don't want to come in. Again, when you're working for small businesses and medium-sized businesses, that cultural weight, if you will, on you is not as heavy as it is when you're working for a large business. And again, as I said, most of the time, Java is going to be leveraged in large organizations who are maintaining legacy code bases. Yes, in the comments below, I'm sure somebody will say, yeah, but I know this one company. Yes, there are always exceptions to every rule. Bottom line is, before you jump into the Java world thinking, this is what I want to do, I always suggest look at the job opportunities in your area. Go to the job sites, check out the job opportunities, check out the companies that are using Java, and make your own assessment. See what's going on. So to wrap up, Java.
Lichess is a chess platform that supports 5.2 million chess games a day with a single core developer. It's a massive platform built with a pretty unusual stack, including some technologies that you may have never heard of, like Scala and Snapdom. This is an incredibly productive developer, and the technology plays at least a small part in enabling these massive gains. Before we dive into the stack, let me share a short anecdote to set the landscape for online chess. This is Vladimir Kramnik. He defeated Garry Kasparov to become the world chess champion in 2000 and defended that title to remain the best player in the world until 2006. At his peak, he was the undisputed best player in the world. But lately, he's better known for the accusations he makes on Twitter. After comparing the over-the-board and online statistics of some high-rated players, he came to the conclusion that they must be
else is doing the same.
I think microservices are technical debt. I think everyone, to a certain extent, makes a distributed monolith. I'm one of these people who thinks that Go is a good programming language.
A week ago, I made a video talking about a blog post that DoorDash posted where they discussed transitioning from a monolith over to a microservices architecture. So they had a Python monolith and they split it into microservices. It's better for a team to own a microservice because it can be deployed independently. And one of the original authors of that post, who's an engineering leader over at DoorDash, his name's Matt. He actually saw that video. And so I got to sit down and actually discuss microservices, and he had actually quite a lot of interesting hot takes. And I definitely learned a lot just kind of hearing his experience over like the last couple decades with microservices. And I think you'll learn a lot from it too. It's just like Google Meets, like the footage itself is just me and him in a Google Meets, but I don't think you guys care about that. I know you guys probably care more about the substantive stuff in the video. So I think it's definitely worth your time.
I'm just one person. I don't speak for the company, but I can tell you how the company is thinking about these things. And it has changed since we wrote that blog post. I think there are some topics about microservices that are really interesting, that if you're curious about this sort of thing, like this is like, there's some tricky bits in here that I think people should talk more about. So what I think the first thing you should start with is really why would you make a microservice? But like, so if I were to ask you, like just in your own, regardless of what I'm doing at DoorDash, why do you think someone should ever make a microservice?
Yeah, I think that's a good question. So it kind of takes me back to just like what exactly is scaling. And so when I was kind of reading the DoorDash post, I initially thought, well, if they got this far with like a pretty large monolith, which of course, like I've never gotten to the point where I'm scaling a monolith to a very high degree, nor have I gotten to like that cusp where it's like, okay, well, this is the line where if you jump over that, that's the point where microservices are worth it. And if you go to the other end of that line, maybe you just want to stay away from them. And I guess maybe this is what you're getting at, where people think that line is maybe changing over time. And I think for many companies, I'm sure it is worth it. My short experience at Google made me realize that, well, if they have all this tooling already set up and they have like a large team of dedicated SREs that are handling all of this, it's probably worth it at that point to, stick with microservices. There's really no need to simplify like the architecture, because we really didn't have to worry about those kinds of issues, like those latency things.
Right.
That was abstracted away from us. And so from that perspective, I think it's worth it.
Google has very mature tooling. They've been at this for longer than basically anybody. And so you would sort of expect that their stuff works really well. Like that's, I guess, you shouldn't be too surprising. But also, you probably can't take what happens at Google and infer too much about how to like make that be advice for anyone else. But so I really want to stick to that, to the why though, because I think it's super interesting. So like, why would you take your monolithic application, doesn't really matter what language it's written in, where there's a single deployable artifact, like one big binary, one big ball of Python code, like one, whatever, language you write it in, but it's like one thing. Inside of it, the modules talk to each other by making function calls. And when you want to change it, you just deploy the whole thing, right? The monolith, right? So like, what would make you ever want to do a microservice? Or I hate the word microservice, honestly. Just what would ever want you to introduce the idea of making gRPCs or RPCs network calls instead of function calls? And I think that the answer usually works out like this. You're cruising along in your monolith and everything's fine. And then your company, starts to get bigger, your development team starts to get bigger, maybe your user base gets bigger, but like the scaling of the traffic is not, I don't think, an issue. I think it's often cited as a reason to do services. I don't think it should be. If it is, that there's probably something very specific about that environment. But there are very high scale monoliths out there. I think it's definitely like possible. But anyway, probably starts to happen is you have a lot of people all want to work on the same thing. Then they start stepping on each other, not while writing the code, but while rolling it out. So you got to roll it out. You cannot just flip a switch. And in this day and age, you never turn your software off. So like traditional software engineering techs, they're all like maintenance windows or whatever. You know what I mean? It's like not of this era, right? So our software, you can never turn off. And in a world where you can never turn it off and you've got like maybe global reach and global audience, you're going to be making changes slowly. So like developer writes code, it rolls out slowly for a day or so, maybe some hours, but not seconds. You know what I mean? It ain't no seconds, right? Well, the problem problem now is if you have one developer or 5 developers, it's probably okay. It takes like 4 hours to do a deploy. But if you have 100 developers, now, boy, they're probably gonna like start stepping on each other where like, oh, there's already a deploy away. So then you go, okay, we'll do a release train. Everybody get on the train, all the changes are gonna go out, they'll all go out together. But now what happens if one of them was bad? If you ship a bug, you gotta roll everybody's change back. And I think this is the reason to do services, is that you have a large engineering team and people are stepping on each other because you're changing it a lot. I think you can imagine other examples of things like why it'd be worth talking over the network, like maybe specialized hardware, like you're doing GPU inference, ML inference, or you've got some other large in-memory data structure, like a map. You're computing ETAs, right? And so you've got a bunch of road vectors in an in-memory, graph. Maybe you'll need a handful of those, right? And then it would be silly to embed that in the monolith, like that big in-memory data structure. Yeah, could be. But like in terms of the micro services where everyone's like, I'm going to move independently, like I think that's what forces you into that. Would you agree with that?
Yeah, I think I would. And of course, like you have much more experience than me in this regard, but I think that's definitely the case, at least in my experience. So you mentioned like, why would you want to make RPC calls from microservices? That kind of reminds me that it's not exclusive from the perspective of like backend development. For example, there was a application, Google Cloud itself. The front end for that is just one really big single page application. And it started out as that. And so there's not RPCs being invoked like from those pages to each other. They kind of actually realized the exact same thing. This single page application, when there's dozens of services on Google Cloud, there's thousands of developers working on it. And they ran into the same problem. If you're going to be deploying it, one team is going to break the other team, and you can't really do anything about that. You're going to have to wait days, weeks. And so they did something very interesting, and I'm not sure exactly how they did it, but they actually made that single page application deployable in independent units. And it was all a matter of like developer productivity. It had nothing to do with the scale. I mean, it's a single page application. It's going to be served the same way regardless, and it's going to hit the same back-end endpoints. Yeah, I think that's exactly right. That in my limited experience, I think I would agree with that as well.
Yeah. Okay, cool. So I think that is actually like, that's like what you just pointed out is an interesting way of saying, well, that's not necessarily doing services, but they found a way to modularize it, to break it up so that people aren't stepping on each other. And, this kind of, there are different approaches depending on what it is, the thing that you're deploying. But somehow the issue of if you got too many people contributing to the same thing and you have to deploy it slowly, that's what makes you want to split it out into services. Okay, cool. I can tell you that DoorDash did not have the luxury of this kind of careful analysis about thinking about like, oh, how should we do our thing? So this was before I joined, but they had the pandemic, and all of a sudden everyone was like, well, I can't go out. We have to order food. And so all of a sudden DoorDash had way more traffic than they had before, and more, and that people needed bug fixed, and new restaurants wanted to onboard, and just like all this stuff, right? So the development velocity needed to increase dramatically, and so they hired a bunch of people, and I eventually was one of them. And but we were just stepping on each other like crazy, like it was not good. And the microservices like kind of effort at DoorDash started with some people just being very practical, going like, well, I've never done microservices before, but I am who works here. So like I'll just do the best I can do, right? And they started, figuring it out, and, kind of kept learning like better ways to do it. We learned a ton, and I would say like some surprising things that I think that I learned about this is, like, I think I've been fond of saying this to my colleagues who all kind of groan when I say it now, but I think microservices are technical debt, and I say that intentionally because in that I do think that they help you move faster at first. I think if you've got a bunch of code running in one place, and somebody says, you know what, why don't you I'm going to write some code over here. You just call me with the thing for a time. That does help that one person, that one team move faster. Like, they didn't have to get involved in this whole team's release process and their development, whatever. They're just like, I wrote my code and I got it working. Now just call me over RPC. colleagues who all kind of groan when I say it now, but I think
Hey, I'm Stanley. I'm a Stanford CS major. I did front-end engineering at Facebook.
Hey, I'm Andy. I'm also a Stanford CS major, and I did platform engineering at Facebook.
I'm Evan. I was on the founding team of Vivo, the music video service.
And I'm Tony. I was a product editor at Square.
And the four of us came together about 6 months ago to work on software for small business owners. But we didn't have a need at first, so we just went out and talked to all the small business owners we could find. After over 100 interviews, we came across a really interesting problem with small business restaurants in an area like this, Palo Alto.
Yeah, so it turns out restaurants in Palo Alto don't deliver, even though they really want to, but they can't afford it. But their consumers are craving for it, but the places that the consumers love just can't deliver. And we also found out about these delivery drivers who had a ton of spare time, and they all want to earn extra cash during that downtime.
Right, and so that's when we built an initial product, PaloAltoDelivery.com. And how it worked is the customer goes to the website and places an online order that gets automatically sent to the restaurant. And then we, as the dispatchers, with some pretty neat routing and batching algorithms, we're able to send the drivers efficiently to get the orders to the customers at a really fast time.
Yeah, and the four of us actually started off as delivery drivers. And over time, we hired more as we grew. And in our first month of launch, with not much marketing, we got over 150 paying customers in the Palo Alto area, which was really awesome. And from that, we generated
like it actually did make it faster for that team, for that one thing. But the problem is, now that this thing is running, it's part of the call graph. It has to be up, right? So I know a lot of microservices theory talks about like loose coupling and what about fallbacks, and does everything have to be up? And if everything has to be up, then you've made a distributed monolith. And that may be true, and it's kind of like not a useful thing to say, I think, because like I think everyone to a certain extent makes a distributed monolith unless you really aggressively do fault injection, like really aggressively. I think you have a distributed, most people have a distributed monolith whether they realize it or not, because they probably don't actually know what will happen if their things slowly grind down to a much lower performance and everything stacks up behind them, or just all kinds of different failure modes. But okay, it's nice, ideal. None of the companies that I've worked for have ever made anything other than a distributed monolith either. Like all the things have to be up. They just have to be up. Right. And so you could say, well, you shouldn't do microservices, and maybe, but maybe you shouldn't. But they are technical debt. They helped people move faster for a time. If there's one thing that I think that I wish people would change their thinking around, it's that idea. Because it's not like it's black or white. It's not like, microservices are bad. Like you got something in exchange for your debt, right? Like you borrowed against someone else's. productivity in the future. And to be clear, the productivity that you're borrowing against is someone else later needs to come to you and say, oh, we have a feature that needs a change to services A, B, and C. And first we got to roll out a change to B. We got to get that thing rolled out. Now we got to roll out a change to B, and now we got to roll out a change to A. Now we got to make sure that the whole thing works, and none of those changes got rolled back. And then later, if you're lucky, we can go back and say, hey, B, you can clean up that code and do a release just to clean up the code. C, you can do it. B, you can do it. But what we find is there's very little incentive to clean up that old code. And it just has a way of like making certain kinds of changes, not only both expensive, because you had to do like 6 deployments there to make one change. You had to do 6 deployments. It's crazy. But also it tends sociologically, like it. My colleague Chris Micklejohn has this phrase where he calls microservices a socio-technical problem, and I think that's a really good way of putting it. It's like it's not purely. If it was purely technical, you would just say like, well, do a good design, do a different design. But like there are people motivations. Someone wants to get this product shipped right away, and they don't care what happens next year. They just want to ship it right now.
Kind of what you're saying is that it's like a people problem. It's like maybe a management problem or just like an organizational problem. I would definitely agree with that. In my experience, we had like a microservice that belonged to a different team originally. And then so we kind of inherited it at one point. And then you kind of mentioned like as the number of microservices grow, it's kind of technical debt. Like there could be consolidation. Like in hindsight, you look at it and it's like, well, these didn't need to be separate. You could consolidate them. And we even got to a point once where we had one service using a data store. And then we thought, well, rather than creating our own instance of that same data store for the second microservice, we could just reuse that same one. And so if they're reusing the same data store, well, then that's kind of feeling like a monolith. But, in that case, we were choosing to do the monolith to go faster, actually. We're saving time by doing that. And then it kind of creates the complicated issue where it's like you don't really know what it is anymore. And you're just optimizing for time. Yeah, it's kind of like a really hairy problem. And I guess I don't know necessarily the solution to it. If everybody had infinite time, you'd kind of clean everything up, but you don't.
For sure. And you must realize surely at this point that the comment threads are going to explode with people saying that microservices should never share databases. Yeah. Like, can you believe that the like absolute just like sacrilege that you've committed there by having 2 services share the same database? Like, how do you live with yourself? I mean, it must be rough. Yeah, I mean, dude, we did the same thing. I mean, like the early DoorDash microservice deployments were just like migrations are hard, and like you want to make us like literally copy the data out of this database in this other database, like So, but anyway, I think the people. I wouldn't say it's just a people problem. I would think if it was, I don't think we would have so many engineers having so many opinions and being kind of wrestling with this challenge. I think it's at the intersection of people at work and people like getting paid to make software, right? And the software itself. And there is a technical component. It's like the software resists being changed by too many people too quickly, right? Like that's the technical problem. It's like if you could find
problem where we had like
what might come after microservices, but there are a couple screenshots when I worked at Uber. There are a couple screenshots in there of a tool that they built at Uber that is super cool, and I've never seen anything else like it. That does try to tell you in a RPC call graph whose fault is it. So like if you're sending back errors, you're burning your SLO, you're doing whatever, like it's your service is in trouble. It's a tool that will tell you whose fault it really is. Usually, I think it's pretty cool.
Interesting, yeah.
Like I think it is possible to build tooling to make some of these microservices problems like less bad.
I think people would be upset if I didn't ask this question. When it came to that migration, was it worth it to kind of go into the microservices direction, or is it more complicated than that in that it helped you initially, but now maybe you're kind of paying that tax, or have you already paid that tax and now, it's just smooth sailing from here? What's kind of the situation right now?
No, I mean, that's a really good question. DoorDash had to do it. They couldn't move any faster with their monolith architecture. Theoretically possible, with enough time, they could have re-architected the monolith and found ways to let more people work on it at the same time. So you found ways of chopping it up and saying like, all right, this is the monolith for you people, and this is the monolith for you people. And, maybe the consumer, browsing is one separate monolith, and the have hundreds of services, 500. I think you need about like 100 to like place an order and get it delivered. I think so. I think that's about right. What was it worth it? Like, well, of course it was worth it, because the company was gonna just the monolith was grinding to its death. It was like overwhelmed that you couldn't fix. No one knew how to fix it in enough time. So like, it was worth it because we, DoorDash still exists, right? Like, here we are. Had I joined the company sooner, I might have tried to steer us into some like slightly different directions, but like, it solved the problem. Like it made it so the company, could keep growing. But at the same time, like, we learned just like a ton about like, what are the hard parts about microservices. And yeah, it's stuff that we talk about in the blog post, but it's all that socio-technical problems. It's like, oh, you want, like, we realize this problem, like, if everyone would just please upgrade their gRPC client, then we can fix this weird interaction that we have sometimes. But there's very little incentive for people to want to like go upgrade their gRPC clients, or pick your other library. Right? So like, now you've got 500 individual things that are running some version of some set of dependencies defined. The average fan out is you make about 1,000 RPCs. And I think that might actually be too low. I think it's more than 1,000. But like, the reason is because of this domain principle. People are like, oh, well, I'm not the consumer profile service, so I shouldn't know about consumer profiles. So then like, you go through this call graph, and every step of the way, someone's like, oh, I need the consumer profile. So then they go get the consumer profile. And you can have caches and stuff, and that's fine. But like, if you make everything have to go out over the network, everything is really going to end up going over the network, like to an absurd degree. Where even simple things that you might think like, oh, could that just be a library? And then someone will say, yeah, but where's the storage come from? And then you have all these philosophical arguments about what's the right way to do microservices. And next thing you know, you have 500 services and 1,000-way fan out on average.
Is like dictating that, okay, well, the solution is just more simple to do it this way, or maybe we just don't
stick to, they're not exactly sure why, and perhaps they stick to them at their detriment. And the example to have, like, if in projects that have a lot of tests, it tends to encourage people to work around the fact that they just want to keep the test suite working. Like, right. It seems like, but serving you or is actually hurting you.
YouTube definitely loves Go.
We say, a monolith, obviously, new framework.
I guess, okay, last question.
To be in the right place, fear of dependencies. Like, I don't like to run other people's code unless it's really important. Industry evolves, technology evolves. Just, I don't know, figure out how stuff works. Just make software better.